Okay, so now the question is, how do you actually find the inverse of a matrix? And by the way, the only matrices that you can find inverses of, if they exist at all, are square matrices. And in particular, only those square matrices that are non-singular. That means the determinant of those matrices is not 0. It's like sort of like you can't divide by 0. So how do you find the multiplicative inverse? Let's just start off with a 2 by 2 case, 2 by 2 matrices. I'll first show you the little formula for it, and then I'll show you how to think about the formula. So here's the formula. Suppose we have A equals, and let's just say it's a 2 by 2 matrix, a general matrix. So I have A, B, these are the entries, C and D. Then the question is, what's the inverse of this matrix? Well, first of all, let me show you the notation. The notation we use to show the inverse matrix is the following. We write, just like with numbers, we write A with a -1 exponent. And that's just read A inverse. And what's the definition of A inverse? Well, it starts off with a scalar. We take 1 over the determinant of A. So you have to compute the determinant of A. That's just that number AD minus BC. That's a number. And you take its reciprocal. OK, and then you scalar multiply that by the following new matrix. It's still going to be a 2 by 2, of course. And what's the recipe? The recipe is you take this diagonal here and you switch them. So I just switch the roles of these things. So I put a D here, and then I put an A here. And then here, actually, I don't do anything but just replace the signs by negatives. So I just switch the signs of these people. And these people, all I do is actually flip these numbers. Okay? So I flipped here and just put negative signs in front of those people there. That should give me the inverse. Let's try it with a particular example. So suppose I take a look at the following. Suppose that A were to be the matrix 1, 3, -1, 5. Then the question is, what's the inverse? Well, the inverse would be, what do I do? Well, first I have to compute the determinant. So I see 1 times 5, which is 5, minus 3 times -1. So that's -3. So 5 minus -3 is actually just 5 plus 3, which is 8. So I take the reciprocal of that. So I write 1/8. And then I multiply that by what matrix? Well, I flip these people. So I have a 5 and a 1 here. And then I put negative signs in front of these people. So I have a -3. And then I have a -1, which becomes a +1. And remember what you do when you have a scalar multiple times a matrix, what you see is just 1/8 times each and every term. So I see 5/8, I see -3/8, I see 1/8, and I see 1/8. I just took every single term and multiplied it through by 1/8. And that should equal the inverse. Let's check it. How would I check it? The way I check would be just to say, OK, well, this product, in fact, should be the identity. Well, let's see what that product is. So if we take that product, I see 1 times 5/8, which is 5/8, and then I add to it 3/8. Well, 5/8 plus 3/8 is just 8/8, which is 1. So that's a good way to start, because that's the first element of the identity. Now, this should be a 0 here. Let's see if that's true. Here I see a -3/8, and then I have a +3/8. That actually combines to give 0. Neat. This should also be a 0. Let's see. Here I see a -5/8 and 5/8. That combines to give 0. And this last term should be a 1. Let's see. We have a -3/8. That's just +3/8 and +5/8. Well, 3/8 plus 5/8 is 1. So look, this actually checks. I get the identity back. So in fact, this really is the inverse of that. So finding inverses of 2 by 2 matrices actually is not that big of a deal. All you do is you divide by the determinant, and then you just switch the roles of these two people along this diagonal, and then these two people along that diagonal, you put negative signs in, but keep them in place. That's all there is to it. Up next, we'll take a look at the slightly more exotic situation when you have a 3 by 3 matrix that you want to find the multiplicative inverse for. Gets a little tricky, but first, let's just revel in the celebration of finally getting this right. I'll see you soon.